Hi there, this is Mr. Eaton with Year 7 video lesson 2.5, and this is some problems that we are going to solve using parallel lines. Don't forget to put the video on pause whenever you need to make some notes, and also while you are trying to solve these particular problems. Alright, so we need to find the angle A, which is sitting over here. A couple of things to take note of in this diagram is there and there is a set of parallel lines. This over here must equal 360 degrees. This over here is 90 degrees. Obviously this is 170 degrees. And we need to solve for A. Put the video on pause and see if you can solve it. Right, so how did we go? Well, we need to find this angle over here. That's angle A. But unfortunately we don't know what that angle is in there because we've given no information. We know that that might be, well, that is 180 degrees because it is a straight line, but we don't know what that is, and we don't know what that is, so we have a little bit of a problem. However, we do know that this over here is a revolution, and therefore that has to equal 360 degrees. Okay, all the way around. So if we solve this angle over here, we should be able to get that angle there because they are corresponding angles. Well done. Alright, so how did we go? I'm just going to shrink this down a little bit and move it up into the corner so that I have a little bit of space to work. So what I'm going to do first of all is I'm going to solve this little problem we have over here. I know that this has to be 360 degrees. I know that is 170, and I know that that is 90. So therefore that over there has to be the difference. And I'll do the sum now. So we have 170 plus 90 equals 260 degrees. And I know a revolution is 360 degrees. Subtract my 260 degrees that I've just worked out means that I have 100 degrees left. Therefore, this angle over here, D, must equal 100 degrees. So, angle BDE equals 100 degrees. Alright, so I'm just going to shrink that down out the way a little bit so I have a little bit more space to work. So that's all good and well. I know what that angle is, but I still need to find that angle there. So I'm thinking about the rules that I've learnt. BDE corresponds to ABC. Therefore this angle in here must equal angle A. So angle BDE equals angle ABC because they are corresponding angles. So quite simply, angle A must equal 100 degrees because of the corresponding angles. Problem solved. Right, well here's a second example. We need to find A. A couple of things we know. First of all, parallel lines. We know that that angle over there is 70 degrees and this angle in here is 60 degrees. Now if this helps, you could actually extend this particular parallel line. So for example, we could extend this line, or this parallel line if we wanted to, as we could extend this parallel line over here. And we could also extend the transversal, which would be this one down here. So that gives us a little bit more information, a little bit more flexibility to try and find some angles. So looking at this diagram now, we know that we've got 60 degrees there. We don't know what A is, therefore we can't find that. We don't know what that is either. We know that that's 180 degrees, but we don't know what that is, so we can't work out that. Same over here, we know that that is 70 degrees. We could probably work out what that is, but that's not going to help us with anything. So we need to focus on this angle over here and this angle over here. And what do we know about this angle and this angle? Well, they happen to be co-interior angles. So angle ABC ABC, add angle BCA, B to C to A, must equal 180 degrees. That angle in there, add that angle in there, must equal 180 degrees. Alright, so angle ABC can be written as 60, add A, and angle BCD can be written as plus 70 degrees, and we know that co-interior angles need to equal 180 degrees. Therefore A equals 180 degrees, subtract 60, subtract 70. Therefore angle A equals 50 degrees. So angle A equals 50 degrees. Well done, you solved that one.